Okay, today we're going to go over reference table pages 8 and 9. As you can see up here, this is the geologic history of New York State. Whoops. Okay, so we're just going to get out our colored pencils, and you can follow along with how I am coloring it to bring attention to the things that I feel like are important for us to focus on. Okay, so the geologic history of New York State. So this is obviously where we'll find everything about the history of New York in the rock record, fossils, etc. So the first thing I want to bring your attention to is eons, eras, periods, and epochs. These are the four main divisions of time in geologic history. And right over here we can see there's a timeline on the side. And if you can highlight right here, it tells us this is in millions of years ago. Okay, so if we start here at the bottom, it says it's 4,600 millions of years ago. So 4,600 million years, we can put that into a simpler form, into billions, which if we think about 999 million, one more than that would be 1 billion. So 1,000 million is 1 billion. So we're going to write that right here, 1 billion years ago. Okay, and then we'll come down to the bottom here at 4,600 million. We can change this to 4.6 billion years ago. Okay, and right here we've got 4,000 million, which would be 4 billion. My pen is a little bit funky, but BYA would be billions of years ago. 3,000 million would be 3 billion. BYA, which is billions of years ago. And 2,000 million would be 2 billion. So 2 billion years ago. Okay, now if we notice up here at the 1 billion mark, come up a little more, and right here it says 500 million years ago. I'm going to make a little mark there. Okay, now if you notice this black line that comes down right here, I'm going to just highlight that, and I would do the same if I were you. Highlight right over this black line. Okay, and come all the way across. And just be careful, oops, to not go over the words so that we can still read the chart. Okay, so if we notice here, this 500 million years ago has been broken down right here into this huge section of the reference table. So up here again we see where it says millions of years ago. Okay, now if we follow this around here, which I'm also going to highlight to bring our attention to. Okay, this also is giving us the timeline information. So this 500 million years ago is broken down here into millions of years ago. So it starts here at 542 million years ago and comes all the way up to 0, which would be present time. Okay, so if you come here to the timeline again, at 0, we want to know what eon, era, period, and epoch we're currently in. We're currently in the Phanerozoic Eon, the Cenozoic era, the Quaternary period, and the Holocene epoch. Those are all the current time periods. Okay, the first thing we're going to do is again break out our colored pencils. I'm going to start with my red, and notice here this entire section of the reference table, which makes up from 4.6 billion all the way up to 500 million. So it makes up about 4 billion years of Earth's history. Okay, this is the first section here is the Precambrian Eon. So I'm going to highlight this in red, and you can color more neatly than I can with my little pen here, but okay, you get the idea. Okay, shade this in nice and neatly in red, the Precambrian. Now notice that name, the Precambrian. That implies it's before something, the Precambrian. Okay, so if you come here, the Precambrian, and then the next time period here is the Cambrian. Okay, and that begins the last 500 million years, which is the more recent period of time. Okay, so the Cambrian is the 542 million year ago period. which is preceded by the Precambrian, which represents about 4 billion years of Earth's history. So lots of time there that we don't have that much information on. As you can see, most of our information is given in this big section here, which is only the last 500 million years. Okay, now notice the Precambrian is broken down into two main sections, the Archean and the Proterozoic. Okay, the Archean here we're going to color in brown, if I have my brown here. Okay, maybe not. Let's go with gray. Okay, if you have brown, go with brown. Not giving me brown as a choice. Okay, well, that did yellow. Let's try, see if I can get gray. Okay, so I'm going to color this in here, the Archean. And notice that the Archean is broken into the early, middle, and late. Okay, now the early, middle, and late Archean, okay, is all the way up to this section here, to the dotted line. This is part of the Archean. So we're going to shade this all the way across to the dotted line. Unfortunately, this doesn't highlight the way the smartboard does in the classroom, but hopefully we're getting the idea of it. Okay, you're going to shade this whole section in. And notice, if you want to look at things that happened in this period of time, I'm going to go back to black. Okay, in the Archean, right here it says oldest known rock. So we could follow this over, and this would have happened about 4.3 billion years ago, right? Somewhere between 4,000 and 4,600 million years ago. So about 4.3 billion years ago here. It's the oldest known rock. Okay, I'm writing 4.3 there. Okay, if you want to see evidence of biological carbon, you'd come right across here, and you could see that that is about between 3,000 and 4,000, so about 3.7 billion years ago. Okay, earliest stromatolites would be come across here. Okay, about 3.5 billion years ago, etc. So everything in this section, you come right across the timeline to figure out how much time, how long ago that occurred. Okay, our next section here is the Proterozoic, which is also part of the Precambrian, and this is also broken into early, middle, and late. I'm hoping I have orange here. Let's see. We don't have orange, but let's go with yellow. Okay, so I'm going to color my Proterozoic yellow. Okay, and you can see this represents time from about 2.5 billion years ago up until 500 million years ago. Okay, so this also is broken into the early, middle, and late. And this we're going to color all the way across here into this gray shaded area. And we're actually going to color all the way down this entire gray shaded area. This actually is bringing this gray section here from about 1.5 billion years ago, bringing this all the way down here to the bottom. Okay, so this whole section here we're going to shade in and come across and shade this all in. If you had orange, great. If you're doing it yellow, that's fine too, as long as it brings attention to the important parts of this table. Okay, so I'm shading all the way across. Everything in this whole section occurred during the Proterozoic. Okay, so I'm going to go all the way up to here. It looks like scribble scrabble, but hopefully you get the idea. Okay, so everything in this section now is from the Proterozoic. Okay, we're now going to move to the current eon, which is the Phanerozoic, and I'm going to break out another color. I'm looking for green, I hope. Oh, we've got green. Okay, so I'm going to go to my green. Okay, and the Phanerozoic, we see right here, okay, is broken into 3 eras. Okay, the 3 eras of the Phanerozoic are the Paleozoic, the Mesozoic, and the Cenozoic. Okay, so first we're going to start with the Paleozoic, which starts at the beginning of the Phanerozoic and comes down all the way across, and the top part comes across here. So it ended about 251 million years ago. It began about 542 million years ago. I'm going to shade this all the way across in another color, purple preferably. Let's see if I've got purple available. Now just notice the globes, they point to the section of time that they belong in. And if you see, this globe and this globe are pointing into the Paleozoic. This one up here is above that, into the Mesozoic. So we're going to just scoop this down when we get here and not shade these above. We're going to shade just these two. This section shows the positions of Earth's land masses through history. So from Pangea forming to Pangea breaking apart into the present day configuration of the continents. So first, let's get another color to color our Paleozoic, and let's go with magenta. Well, let's do cyan. I think that's a blue. Okay, so I'm going to color in. I'm going to highlight the Paleozoic. You should be coloring in every single thing in this section, including scooping down here. So all the way across, you're going to color this whole thing in, either in purple or a light blue, whatever color, as long as it's shaded in the same color. Okay, so this will all be shaded in. I'm going to do this kind of roughly just so you get the idea. This should be all shaded in our light blue or purple. Okay, so shade all the way across. Just do it nice and lightly because there's still other things we're going to label on here. So I would like this to be as neatly as possible so when we color these other sections you could see your shading and coloring and the notes that we're going to write on here. Okay, so this whole section, color in. Feel free to pause this at any point to catch up and continue, then catch up back up. Now I'm going to color the Mesozoic. I'm going to try for a pink color. Okay, I guess magenta is as close to pink as we're going to get. Okay, and the Mesozoic is this part of the Phanerozoic. Okay, and it comes down across here, all the way across, and again we're going to just keep these two globes in here. Okay, and then shade everything in this section. Okay, so everything in here is going to be the same color. Everything in this section, shade the same color. Okay. All right, so this is the Mesozoic, which represents 65.5 million years ago up to about 251 million years ago. Okay. And last but not least is current era, the Cenozoic, which I'm going to see if I've got another blue, which I do. Blue. Okay, and we're going to color this Cenozoic in blue. Okay, all the way across. Okay, including this most recent period of time, all the way to the top. So shade this entire section in, all the way across, nice and neatly in blue. Okay, I'm going to pause here because once you've caught up to me, I'm going to move on to another section. I'm going to write a couple more notes on here and have you catch up. Okay, so I'll come out of this screen and start fresh. Okay, so there's a couple of notes that I want to put on here that I think are important for us to keep in mind. Okay, one over here in the important geologic events, you'll notice they use the word orogeny whenever we've got these little mountain drawings. So I want to define that in here since that's an often forgotten term. Okay, if you remember, an orogeny is simply a mountain building event. So we're going to write orogeny, and I know my writing is terrible in here, but is mountain building. Okay, so mountain building. Write this nice and neatly and smaller than I'm able to on this here. Okay, so mountain building. Maybe I'll get better at this as I practice. Okay, orogeny is mountain building. I look like I'm writing like a first grader. I apologize. Okay, another thing I would like to add down here is index fossils. As you can see here, index fossils are on the bottom of this page. So one thing I want to bring your attention to, and find a space over here. This is probably a good space for you, but it's not a good space for me right now. Okay, index fossils. Okay, we talked about how they're good indicators of time as well as volcanic ash. Okay, both of those, index fossils and volcanic ash, yikes, ash are good indicators of time. So both of these are good indicators of time because they occur over a wide area, I'm not getting better at this, geographic area, a wide geographic area, and they both occur in only for a short time. So with index fossils, they only live for a short time. In geologic history, a short time is different than what we would recognize time to be. Volcanic ash also occurs in a geologic instant, a very short amount of time, but they spread over a wide area. So they occur over a wide geographic area and only for a very short time, which makes them really helpful for narrowing down periods of time. That's geographic area in a short period of time. In a short period of time. Okay. Okay, so index fossils and volcanic ash occur over a wide geographic area in a short period of time. I need to get better at this pen. It's very sensitive. Okay. So now, the next thing I would like to bring your attention to is this Life on Earth section. Okay, and this goes through different, from about 1,300 million years ago, where they find abundant stromatolites in the rock record, up through the entire Phanerozoic, the Paleozoic, Mesozoic, and Cenozoic, showing us the progression or evolution of life on Earth, when we find the first fish, when we find the first dinosaurs, the first humans, etc. Okay, so this is a good section to take a look at. The New York rock record here tells us when we find what kind of rocks we find in New York State and when they were formed. So we have sedimentary rock here, here, and then we've got bedrock here, here, and here. And you'll notice there's some gaps, which if you remember, what we call those gaps in the rock record are unconformities. So we actually could write that in here too. If you can write this again more neatly than me, this would be an unconformity. Right? It's a gap in the rock record, unconformity. And try and write this smaller than me. Obviously, I'm having pen troubles. And unconformities are going to be, whoops. Okay, so again, just write the word unconformities in here. So everywhere you see these gaps, those are places where the rock record was most likely eroded. Okay, now the other main section that we need to go over. Right here, the time distribution of fossils. Okay, these are the index fossils, which I'm going to write that up here also. Let's get my pen on. Okay, these are index fossils that are found in New York State. Okay, index fossils found in New York State. That was better. I'm getting there. Okay, if you turn your reference table sideways, if it's easier, you'll see that there's these bars here that represent different organisms, different groups of organisms, and then there's letters, A, B, C, up through Z. Okay, so on the first bar, take a look. This is the Trilobites. So this is a particular type of organism, and we've got A, B, and C. If you come over here, you'll see we've got A, B, and C. Okay, so A, B, and C represent three different trilobites that existed back in Earth's history. Now notice that the bar has a beginning and an end. Okay, so it ends here and it begins here. This represents when trilobites are found in the rock record and when we no longer find them. Excuse me. So if we look over here, I'm going to go to my red pen. You can highlight this along with me so we can get the hang of this. Okay, I'm going to highlight carefully, shade over into the red, my ABC, my whole bar here of trilobites. And then I'm going to come over here and do the same thing with these three fossils. So A, B, and C are trilobites. Okay, A, Elliptocephala, right here, existed, if you follow across right here, in the Cambrian, in between the early and middle Cambrian. and then it went extinct. Okay, later on we find this B fossil, which is Cryptolithus. Cryptolithus existed in the Middle Ordovician. Okay, so when we find that fossil, we can narrow down that that rock was formed during the Ordovician. Okay, then it died off. Then finally C, Phacops. Okay, Phacops is found in rock that is dated to be Middle Devonian. Okay, and then it died off. And then the entire Trilobite evolution ended about 251 million years ago. It says mass extinction of many land and marine organisms, including trilobites. So we don't find any more trilobites in the rock record after that. Okay, so we're just going to go through and highlight the different fossils that go with each bar. Okay, so I'm going to pick green here. Okay, I'm going to go over this next group, which is Nautiloids. Okay, Nautiloids do this much more neatly than me. You can see began here, and they still exist today. The bar goes all the way to the top. Nautiloids, we've got D, E, F. Come over here to D, E, and F. Okay, and highlight these in the same colors you did their bar. And these three fossils are index fossils of Nautiloids. Okay, then our next fossil bar are Ammonoids. They've got just the G there. So we're going to highlight that. I'm going to do blue. And I've got Ammonoids existing from here and dying off here. And here's my G fossil. Okay, and then I've got my next one, my next group, okay, is the Crinoids. And they came into existence, they're found about here. We've got our HI index fossils for crinoids, and notice they still exist today. Fossil bar comes all the way to the top. And these are our HI fossils. Okay, then we've got JK, graptolites. Okay, notice graptolites. Do they still exist today? Okay, if you look at our graptolites, we've got the J and K fossils. And it ends right here, so no, they don't exist still today. They've gone extinct. Okay, here's our J and K. We've got Tetragraptus and Dacelygraptus. And our dinosaur bar. Okay, our dinosaur fossil bar. We're doing yellow. We've got an L for our index fossil. Dinosaurs went extinct right here. Found in the rock record right here. Went extinct about 65.5 million years ago. Mass extinction of dinosaurs, ammonoids, and many land plants. Okay, here's our L fossil. Colophysis. Okay, now we're going to move over to M and N, the Eurypterids. Go back to red. I'm limited to colors. You can feel free to use different colors. M and N, the Eurypterids, which went extinct right here, came into existence here. Okay, here's our Eurypterids. Which just happens to be Eurypterus, our New York State index fossil. Okay, mammals. Okay, mammals not found until pretty recently. Okay, they came into existence. I'm going to do green. Okay, mammals began right here, which is a little over 200 million years ago, and obviously still exists today. The O is our index fossil, which it represents both the mastodont and the beluga whale. Okay, I'm going to go to our next fossil line. Back to blue. And this would be vascular plants. Vascular plants, which are still in existence today, found in the rock record beginning in the Silurian. We have P and Q for those index fossils. So we've got the Naples tree, Cooksonia, and Anurophyton right here. Okay, placoderm fish. Very short existence here. Okay, came into existence in the Silurian, went extinct by the end of the Devonian. Okay, that is our R fossil right here. And we've got S, birds, right here, found in the Jurassic, still found today. Okay, we've got the condor here as our index fossil. You can see the condor existed during the Quaternary period. Okay, our next group is the TUV index fossil of corals, which corals still exist today, as shown by the fossil bar extending all the way to current time. Okay, our oldest corals, the corals that are found in our index fossils in New York State are these three right here, T, U, and V. Okay, so T fossil, Lacanaria, existed during the Ordovician. U, the Cystophyllum, existed during the Silurian, and Pleurodictium existed here during the Devonian. Okay. Now, our last two groups, we're going to color. Go back to red. Okay, we've got our W and X fossils, which are gastropods. Whoops, still in existence today. Keep your lines nice and straight. Okay, came into existence here in the Cambrian. WX are right here. And finally, our last group here. I'm doing green. I've got my Y and Z brachiopods, which also still exist today. Okay, so now we should have colored the entire reference table and also highlighted our fossil bars and brought attention to which fossils belong on those bars. So we should be able to get a hang of how this reference table works. You know, over here in the important geologic events, just want to highlight this here. Geologic events. Often a question may ask you about a particular geologic event in New York. So note the wording here. It gives you some main events of plate tectonics, of mountain building throughout Earth's history in New York State. Okay, and also the positioning of North America is bolded in this section here for us to see how North America is believed to have moved from 458 million years ago up until this showing 59 million years ago to the present time map. Okay, so hopefully you have this all colored, and talk to you soon. See you in class.